You've seen it 1,000 times. The horns, the frill, the three-pointed skull charging straight at a T-Rex. It's in every museum, every textbook, every movie poster from the last 100 years. And it's wrong. Not slightly wrong, not open to interpretation. Completely, fundamentally wrong. Triceratops didn't use its horns to fight T-Rex. Scientists figured that out years ago. And then they buried the discovery in academic journals where almost nobody would find it. This is the story of the most recognizable dinosaur that ever lived, and the 150-year lie that every single one of us was taught to believe. Let's go back to 1887. Othniel Charles Marsh, one of the most famous paleontologists of the 19th century, is staring at a pair of enormous horn cores pulled from the rock of Colorado. He thinks they're from a giant prehistoric bison. A year later, a full skull arrives. 3 horns, massive frill. A face unlike anything he's ever seen. He names it Triceratops, 3-horned face. And from the moment he publishes his description, the interpretation is immediate and absolute. Those horns are weapons, built for combat, built to fight. The image locks in within a decade. Triceratops charging T-Rex, horns lowered, frill raised, the ultimate prehistoric showdown. It goes into illustrations, then into textbooks, then into museum dioramas that children stare at for over a century, then into Jurassic Park, into toy boxes, into the cultural bedrock of everything we think we know about the Cretaceous period. And nobody stops to ask the question that should have been asked in 1887. What if those horns weren't weapons at all? What if we built an entire mythology around a structure we never actually understood? Here's what the fossil record actually shows. Triceratops lived in the late Cretaceous, roughly 68 to 66 million years ago. It was large, very large, up to 9 meters long, up to 12 tons. A body built like a tank, moving on 4 legs with a skull that could reach 2.5 meters from snout to frill. And those horns. The 2 brow horns alone could reach 1 meter in length. Sharp, dense, structurally impressive. But here's what biomechanics researchers started noticing in the 2000s. When you model the impact of a Triceratops horn strike against a T-Rex body, the physics don't work the way the mythology suggests. The neck and skull of Triceratops weren't designed for the violent downward thrust required to gore a large theropod. The angles are wrong. The muscle attachment points are wrong. The stress fracture patterns on recovered horn fossils don't match the pattern you'd expect from combat with another large animal. They match something else entirely, something far less dramatic, something that completely dismantles the image that has defined this animal for a century and a half. In 2009, a team of researchers published a paper that should have made global headlines. It didn't. It landed quietly in a paleontology journal. It got cited by specialists, it was discussed at conferences, and then it sat there, mostly ignored by the world, while every museum on Earth kept its Triceratops charging at T-Rex. The paper analyzed the microstructure of Triceratops horns and frill, using techniques that weren't available to earlier researchers. What they found was a vascular network, a dense web of blood vessels running through the frill tissue. Not the structure of bone built for impact and combat. The structure of bone built for blood flow, for temperature regulation, for display. The frill wasn't armor, it was a radiator, a signal, a screen. Further analysis showed that horn shape varied dramatically between individuals, and those variations correlated with age, and likely with sex. Young Triceratops had shorter, straighter horns. Mature individuals had longer, more curved ones. That pattern, in biology, has one primary explanation: sexual selection. The horns weren't built to fight T-Rex. They were built to impress other Triceratops. Now, stop and let that land for a moment. The most iconic image of prehistoric combat, the three-horned tank lowering its head to charge the tyrant lizard, is almost certainly fiction. What Triceratops was actually doing with those horns was closer to what a peacock does with its tail, or what a male elk does with its antlers in mating season. It was showing off. That doesn't make Triceratops less impressive. If anything, it makes the animal more complex. A creature with sophisticated social signaling, capable of communicating status, health, and reproductive fitness through the very structures we spent 150 years misreading. And the fights? They likely happened, but not against T-Rex, against each other. When paleontologists examined healed bone damage on Triceratops skulls, the kind of damage that occurs and then repairs during the animal's lifetime, they found patterns consistent with horn-to-horn contact. Triceratops fought other Triceratops, rival males locking horns, pushing, displaying. The same behavior you see in bison, in deer, in goats. The horns worked exactly as evolution intended, just not the way Hollywood told you. But here's the question that nobody in the popular science world bothered to answer publicly for years. If the research was published in 2009, if the evidence was clear and the scientific consensus shifted, why is the Triceratops charging T-Rex still the dominant image in museums, in films, in children's books, in merchandise worldwide? The answer is uncomfortable, because correcting a 150-year-old myth is expensive. Museum dioramas cost hundreds of thousands of dollars to build. Textbook publishers don't rewrite chapters mid-edition cycle. Hollywood doesn't reshoot scenes because a paleontology paper came out. And toy companies certainly don't recall action figure lines because the science moved on. So the myth persists, not because scientists still believe it, but because the infrastructure of the myth is too large and too profitable to dismantle quickly. This is not unique to Triceratops. This is how science actually works in the real world, where discoveries happen in journals and culture catches up decades later. Sometimes it never catches up at all. You are watching this video. That puts you ahead of approximately 99% of the people who still believe the story they were told as children. Let's talk about what Triceratops actually feared. Because T-Rex was real. They shared an ecosystem. The fossil evidence for T-Rex predation on Triceratops is solid. Bite marks on Triceratops bones, healed and unhealed, confirm that T-Rex attacked them. But the dynamic was not what the movies show. A healthy adult Triceratops, 9 meters, 12 tons, with a skull built like reinforced concrete, was not easy prey. T-Rex was an opportunist. It targeted juveniles, the elderly, the sick, the isolated. The horn display that evolved primarily for sexual competition may have served a secondary function, as a visual deterrent, a signal to predators. I am large, I am healthy, I am expensive to attack. This is called aposematism when it involves color. When it involves size and structure, it's called honest signaling. Triceratops horns were honest signals. Not weapons in the Hollywood sense, but not useless either. They were communication, directed at rivals, at potential mates, and perhaps at the largest terrestrial predator that has ever walked the surface of this planet. A language written in bone, a meter long, curving forward from a skull the size of a car. 66 million years ago, an asteroid ended everything. Triceratops was among the last to go, one of the final species standing before the impact winter collapsed the food chain and silenced the Cretaceous forever. But it leaves behind something strange, the most misunderstood animal in paleontology, a creature whose real biology, complex, social, visually sophisticated, is more interesting than the myth that replaced it. The three horns were never weapons against T-Rex. They were a language. And for 150 years, we didn't speak it. We just assumed. That's the most human thing about this story.